Hey guys, welcome to our new week on trig ratios. So this week we're going to start talking about how we can use some ratios to help us identify sides and angles in right triangles when we don't necessarily have two sides or we don't have special triangles. Maybe we only have a side and an angle and we can find all the parts. So if you take a look at this kind of first picture here, trig ratios are the ratios between sides of a right triangle. So that's really important. So we're going to be kind of focusing on sides right now. So these kind of come from the side, and then you're going to see a new symbol down here called theta. That is just representing this angle that we want to find. And so it kind of looks like a zero, but it's called a theta. Okay, so from this theta, the first thing we need to understand is, what do we call the three sides? Okay, what do we call the three sides? So if you look at this theta angle, if we go across from it, okay, if we go across from it, this is what we would call the opposite side. So this is the opposite side, okay? We already know that this is the hypotenuse. And how do we know this is the hypotenuse? It is opposite of the right angle. And then the angle next to the theta is called the adjacent side. Now, something to remember, down here, the hypotenuse is always across from the right angle. We've already talked about that. The opposite and adjacent sides are dependent on the angle. Okay? So what that means is, if this was our theta up here, so I'm just going to change it and mark this. If we were looking at this angle, then this would be our opposite, and this side right here would be our adjacent. Okay, and so that is going to be really important when we're looking at that. So I'm using color. You don't necessarily need to write that down, but it is important. Okay, here is how we remember the three ratios. Okay, so we use something to help us remember this. Sine is our first ratio, and the ratio of the sine of that theta angle is a fraction. Ratio means fraction, and we're going to take the opposite side over the hypotenuse. Okay, so we remember sine by the word so, S-O-H, so. Okay, cosine, we remember it as co. Okay, so we'll show you what that means, but it's the adjacent side over our hypotenuse. And so we remember cosine with a capital C is A over H, adjacent over hypotenuse. And tangent, we remember as the opposite side over the adjacent side. And so we remember that as T and then O over A. So your saying that you will always use to help you remember is so ka toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And toa, T, tangent, is opposite over adjacent. Okay? So here we go. Let's take a look here at this kind of first example down here. So remember, we're going to use the sine of the angle, so, ka, and toa. Okay, so if we look at this example, if we have the sine of A, so A is our angle. I'm going to mark that right there as our angle. Okay, and so from A, this side across would be our opposite. This side would be our adjacent. And this side would be our hypotenuse. I think it's always important to mark that. Okay, so if I want the sine of A, I need the opposite over the hypotenuse. So the sine of A would just be the fraction 4 over 5. That's it. That's the ratio, 4 over 5. If I want the cosine, if I use my pointer here, the cosine of A, I need adjacent side next to over hypotenuse. So that would be 3 over 5. And then if I do my tangent, I do the same thing. Tangent of A would be the opposite side over the adjacent side. So it would be 4 over 3. Okay. Now, if we change our angle and come down here to C, now my opposite side has just changed and my adjacent side has just changed. Okay. So if I do the sine of C, I need opposite over hypotenuse. So I'd have 3 over 5. And now remember, you can always turn that into decimal, and we'll practice that on our later by dividing those two. The cosine of C would be the adjacent side over the hypotenuse. So this time it would be 4 over 5. And the tangent of C would be the opposite side over the adjacent side. So it would be 3 over 4. Now, if you look at these, they look like when we take the two different acute angles, they just kind of switched a little bit. So kind of notice that they're kind of inverses of each other. All right. Let's come down here and try kind of our last few examples down here. Okay. If you want to pause, you could try these on your own and then check them as we go. So this first one, it says, what are the sine, cosine, and tangent ratios of angle F? So angle F is right here. So if that's angle F, that means 9 is my opposite, 12 is my adjacent, and 15 is my hypotenuse. So if I want the sine of angle F, I would do would be opposite over hypotenuse. So I remember that would be 9 over 15. And then you should probably simplify that. 9 over 15 would be 3/5. Okay. I'm going to kind of run out of room, so I'm going to get rid of that. Okay. Cosine of F. Well, the cosine of F is adjacent over hypotenuse. So that'd be 12 over 15, which is 4/5. And the tangent of F would be opposite, which is 9 over adjacent, which is 12. And that would be 3/4. Okay, it turns out to be the same one, just times 3. Should have probably picked a different triangle, I guess. Whoops. Oh well. So these will kind of be fun. So this last one we'll do the same idea here. Okay, we're going to do of H, but this time I'm going to go to a decimal. I'm just going to show you how we can make them a decimal. Okay, so if we have the sine of H, so this time we're going from H, that makes this our opposite. This our 9 is our adjacent, and 15 again is our hypotenuse. So we got the sine of H would be 12 over 15. And to make that a decimal, we just divide them. And so if you divide 12 by 15, we get 0.8. Okay. And then if we do the cosine of H, the cosine of H would be the adjacent side, which is 9, over the hypotenuse, which is 15. So we go 9 divided by 15 is 0.6. Sometimes they're really messy, so then we round. We're going to go, on your practice, you're going to go to the 4th decimal place. And then tangent of H, this time would be 12 for opposite over 9, which is adjacent. So if I do 12 divided by 9, that is 1.3 repeating. So we'll go out 1, 2, 3, 4 decimal places. And that is how we find our trig ratio using sine, cosine, and tangent. So some new words for you, but a good thing for you to go to and practice Whatever questions you have, make sure you ask.